to another episode of Technical. So last week we kind of switched our conversations up, like in company conversations to Tisa Nacho. You should really follow that. It's an interesting podcast, and switch to more guest stuff. But this conversation is more technical. So yeah, we thought we'd put it here, and it's an interesting one today. So I'm joined by Ed. Or should I say Engineer Jabuka? Honorable Engineer.
Oh, come on. Yeah. Well, at least I collected the papers yesterday. So yeah, I have the thing now.
Congratulations,
man. Can use it. Thanks, man. Yeah. It was nothing.
Yeah,
I was just hanging out with people.
Please. You disappear for 3 weeks at a time and we'd see you stressed and be like, yeah, man's putting up a brave face, but chaka.
It was chest pains, man. Chest pains.
Yeah. So today, since it's a technical conversation, I am saying technical because I'm the president of an engineer, but I have my own thoughts as well. Maxwell, surname, I hate like saying people's surnames wrong. Chikumbutso, Maxwell Chikumbutso, I think founder of Safe Technologies.
Yeah.
He's been in the news. We've reported on him a bunch of times. There was the drone, then there was the what's it called? That battery. What's it called? Perpetual.
It was a generator. According
yeah.
to the article.
Yeah, a generator.
Yeah, it was an EMF generator.
Yeah. So yeah, that one raised a bit of raised some interesting conversation amongst the Texan community way back when. I think it was 2016 or 2017. I'm not sure. But yeah, it was interesting. There was a helicopter.
Then.
Yeah, there was a helicopter, and then the car that didn't need a charge. Which all of these things were really interesting, and yeah, you could see people's comments. They're like, isn't this just repackaged technology from something else or whatever? Well, that aside, so on the 11th of January, which is this week, the Herald reported innovator develops cordless television set. Gifted inventor Maxwell Chikumbutso has set his sights firmly in revolutionizing the information technology gadget sector by developing a radio frequency powered television set without a plug. So essentially, it's being powered by radio frequencies. Now, to be honest, I never enjoyed physics at school. I regret it, but I was like, this is Nobel laureate kind of thing, because like CES. I remember the other editor on Texan, Leonard, reported on that cordless remote, cordless remote. It's that remote that's charged off radio frequencies. That was a CES off the TV kind of stuff. It was really cool. So when I saw this, I'm like, oh, okay, interesting. And then obviously I deferred to, so let me continue the story. This move will certainly widen access to TV media content and producers and products for millions of people in Zimbabwe and Africa with no access to the main electricity grid. Chikumbutso succeeded in embedding the wireless power generator that uses radio frequency energy on a 55-inch UHD Samsung TV, set to eliminate the use of power cables, on-grid power, and the size of TV power supply gadgets. His quote from it is, "It has no cables connected to it. It is self-powered. When you look at the rear end of the TV set, TV instead of the glossy front, what is notable is that it doesn't have any cables connected to it," the multi-talented inventor told the Herald on Tuesday. So, like I said, I deferred this to a man who's way smarter than I am. Edwin, engineer. Sorry. Engineer.
Oh my gosh.
So
come on, man.
I talked to Ed about this last night.
Just a regular dude.
Yeah, that's what you say. I talked to Ed about this last night, and I had my reservations. I'm like, this is, like I said before, like Nobel laureate stuff. Like, you'd be a Nobel Prize winner for this, and this is like super revolutionary. Like, at least in my mind. I don't know, Ed. Can you give some structure to what I'm trying to say?
Man, it's impressive stuff, man. Like, if that was possible, imagine this, because most of the devices we use already communicate wirelessly. Most of them, your smartphone, your laptop, your tablet. Imagine just walking around with your phone in your pocket, and it's just charging. Yeah, you're just walking in the streets. You're taking a walk in the CBD and it's charging. You know, it's good. It's covered. And then you get into a bus. You're using, well, if it was the first world countries, you'd have like Wi-Fi on a bus so you could enjoy some internet on your way home. And instead of that internet consuming your battery, it's also, adding to it. Imagine a future like that. Wait, I mean, Apple will be happy, very happy, because Apple has been on a rampage removing ports and buttons. So Apple will be very happy to just have such a technology where it's like, hey man, the iPhone is just a slab of metal and glass. There are no buttons and there are no ports. It's just a slab. But yeah, like if you kind of then look at the way it then works, like how these radio waves work. The more you try to understand how radio waves work, the more you start to realize that there's a bit of a problem here. And for me, the biggest one was the fact that the amount of power that you are saying you can obtain from radio frequencies, enough to power an electric car, enough to power a home. I mean, okay, so a bit of context. Here's the thing. Remember when 5G was announced?
Yeah.
And a lot of people were saying it's causing corona. And some were sending videos saying it's killing some plant life and animal life because the amount of energy being radiated is too strong, right? All of that was fake news. 5G might cause some electrical interference, but it doesn't affect biological stuff. And so, just looking at that, a lot of debate was said about people saying, guys, are these things safe? Are these waves that we are just chucking into the air safe? And the answer to that is, by the time a product is put into the public so that the public can use it, it's gone through some testing to ensure that people won't get affected by it. And this testing happens for a while. So for example, I think in the news, China says to be close to finishing up its 6G technology. That's the next evolution that's going to replace 5G, right? But they started working on 6G soon after the announcement of 5G, which was probably 2-3 years ago. That's when they started working on it. So these things go for years whilst they're trying to develop them up until the point where they're like, hey, we can chuck these things out. But some of those tests now involve checking how much radiation is being produced and where the limit is, so that when a designer designs this system, they make sure that their system falls within certain parameters so that it's fit for public use. It doesn't affect people in any way. And that's what's gone through a lot of these communication devices. Your Wi-Fi router is emitting a radio wave that your computer and your smartphone and your laptop receive, and that radiation is internet. But these devices that are receiving this signal, they're receiving a signal which is, in terms of power levels, it's like really small power, I mean, yeah, like tiny power, tiny amounts of power, just so that they can detect something that they can then convert into whatever internet that you're using, or if it's Bluetooth, whatever music you're playing via your Bluetooth headphones and the like. So these are not powerful waves, powerful enough to power anything that significant. So that then kind of made me ask a bunch of questions when I saw that in the report. They were saying this device that's connected to the back of the TV supposedly can grab up to 500 watts and 15 amps from radio waves. 500 watts and 15 amps. Yeah, I mean, that literally can replace solar panels easily. If it were viable, it can literally replace solar panels.
So
but then
before you go on, I wanted you to just explain to me and the audience what a radio frequency is, because it's like, okay, this is technology, but what is a radio frequency?
Ah, yes, yes, yes.
What is radio
Okay,
frequency?
so
Not a radio frequency. What is radio frequency? Sorry.
so, so basically, like uh, when you're communicating, you are sending a signal from point A to point B, and this signal travels in some sort of a wave. And well, the basic principle of a wave is it's got ripples, and these ripples, there are a certain number of these ripples that exist in a specific period of time, which then is what we call frequency. And the number of those ripples that are in a second will determine which kind of frequency it is. So radio frequencies have a certain number of those ripples within a second. So it's just the shape of the wave. All waves are the same, they're ripples.
Okay, so how's that measured? So I saw online it was measured in hertz.
Yeah, it's measured in hertz. So these ripples are repetitive. So repetitive in the sense that they cycle up and down. And each of these cycles, the number of these cycles within a second is what's then referred to as frequency, and it's measured in hertz. So 1 hertz is 1 cycle, complete cycle that occurs in a second. Think of it as a rotating wheel. So the number of rotations a wheel makes, that's the frequency. So that's pretty much radio waves as well. Okay. Just instead of a wheel, it's a ripple, like a ripple in water.
It's just like revolutions per minute on your was it odometer or something?
On your odometer, yeah.
But it's just per second.
So it's per second, not per minute.
Okay, cool. So in terms of harnessing power from radio frequencies, I was looking online and it's like, yeah, it's possible, but the amount of power you're going to get is pretty minimal. So that's when I got kind of confused with the difference between voltage and amps. Like those are two concepts that, to me, they make sense in my head, but I could never properly explain the difference between voltage and amps.
Oh yeah, like even for me, that's a very difficult thing to explain. So how I would usually explain it is, think of it as a pipe. Yeah, think of it as a pipe. So voltage is the size of your pipe in terms of its diameter. So how big is this pipe? That's your voltage. And then your amps, which is your current, is how much stuff is flowing through that pipe. So that's kind of a way that I got to understand it. Voltage is the size of the pipe, how big it is, and then current is how much stuff you can pump through the pipe.
Okay. Interesting. So when it comes to powering a TV, so the report said, you said it was 500 watts, something like that.
Oh yeah, 500 watts and 15 amps.
Yeah. How feasible is that? So how much does a normal home outlet put out, like in terms of just amps and volts? How much does it put out?
Oh yeah. So your square plugs, those square plugs, those 3-pin square plugs that we're used to in the household. If your electrician did it by the book, that should be a maximum of 10 amps out of that socket. 10 amps. So the maximum voltage in Zimbabwean households is between 220 and 240 volts. So just using 220, that's 220 times 10 amps for you to get your watts, which is 2,200 watts. So that square socket should only be able to output 2,200 watts, which is decent. You can plug in a lawnmower, it will sort it out. You can plug in a heater. It'll not find any problems. You can plug in an iron your clothes, because those are some of the big power consumers within the household. You can't connect a stove. A stove actually has its own line, because a stove can use up to 30 amps. So an electric stove, it has its own line and its own circuit breaker, and then your plugs have their own. But then some households have round plugs, and those round plugs are rated for 15 amps. So higher rating, so that you can do more with them. You can connect heavier appliances to a 3-pin plug than on a round plug than on a square plug. So yeah, like that's a lot of amps. 15 amps is a lot of amps.
Because
So it's
when I saw the report, I was like, 500 watts, 15 amps. That sounds like quite a bit. So the quote from him by Maxwell Chikumbutso says it produces 500 watts with 15 amps. That means that TV can also power additional 2 by 100 watt light bulbs to light a house. So the thing with the report, I didn't see a demo video, and I looked on YouTube to try and see a demo video about how this all works. And I couldn't find one. Maybe one of the audience might have one. Link it below if you're on the blog. But I couldn't find a demo video because I was like, oh, okay, this is really interesting. But how does it do that? So when we go back to radio frequencies, it's like, okay, how can an antenna, oscillate, I guess is the right term, enough times to a receiver that is capable of powering a TV at that? So I don't know what the minimum is. So I don't know, maybe, how the minimum amps, volts, watts that you can convert, because there's some devices that kind of work in that way. So dumb question. How do wireless chargers work?
Oh, so wireless chargers, that one is simple. So what you have is you have a coil. So a coil on the charger itself, and you just, your normal two wires that you just coil up. And then what then happens is, if a current passes through it, so let's say a pulse of current, as it passes through that coil, it generates what's known as an electromagnetic field. So essentially what happens is, whenever electricity is passing through a wire, it is sort of magnetized. There is some magnetism going on due to that flow of electricity in that wire. So if you then make a coil, you are sort of concentrating this magnetic field, and it becomes a stronger magnetic field. And so if you then alternate this current, so alternating current is current that moves in ripples, that alternates from negative to positive. And that's pretty much the power that comes out of your socket. That can then generate an electromagnetic wave that you can pass on to another coil. So another coil being the one that's in your phone now. And this coil, when it receives this electromagnetic field, it'll then convert it back to electricity. And that's how your phone then charges. So it's just one coil in the charger sending some magnetism vibes to the magnet to the coil that is in your phone, and then your phone starts charging.
Okay.
That's pretty much how it works.
So that's why proximity matters for these chargers. Like you have a pad, proximity, you have to put it on something for it to actually work in that fashion.
Exactly, because like these magnetic waves, their power decays rapidly, almost exponentially, as you move away from the coil that's emitting this radiation. So because of that like rapid decay, the most efficient way to charge is if these coils were actually touching each other. Like that's how you would get the highest or the maximum power transfer from the charger to the phone. But then the phone is a back glass, and this coil on the other end needs to have a cover. So they then just work out how much charge they'll be able to chuck into the phone with these two layers included. So that's why, like, if you have a thick pouch on your phone and you want to use a wireless charger, that might not really work, because the distance from the distance between these two coils is now just too big for there to be any meaningful power transferred from the charging coil to the receiving coil in the phone.
Okay, so that answers that, because like I was, when I was reading up on it last night after we had that conversation, I was like, it would make sense for low powered objects like that remote that was at CES. It would make sense for low powered objects, like things that don't continuously need a consistent power supply, or that might need a consistent power supply, but a very small one. But when it comes to so I was talking about radio frequencies. When it comes to powering a TV what kind of antennas would you need, and what kind of how efficient would you need it for it to work in this manner? Because my mind is still boggled
to work.
Yeah, because like I mean, my science
Yeah,
is high school,
mine
right?
too.
Yeah, my mind is boggled at how this could have possibly worked. Because when again, you know, you
Mm.
see a report and you're like, but okay, and you go through it, and then there's
How?
not much
How does this
explanation.
thing?
There's not much in terms of detailed explanation as to what exactly is going on here. I'm not sure. I don't know. Maybe it's a patent thing, but
Mm.
if this was a thing, it probably would have filed a patent, or it probably already has. Um,
Yeah.
yeah. So for me, I'm finding it hard to believe. Like I'm really finding it hard to believe.
So
Um,
here's the thing. So the thing is, and yeah, all 90s babies will understand this one. You
mm,
know those speakers we used to put on our desktops,
yeah.
like those plug-in speakers. You remember that whenever the PC was on and running and those speakers were on, if you were about to receive an SMS or about to receive a call, you would hear some feedback.
Yeah.
Yes, that's what. So that actually shows you that there are devices that can detect these radio frequencies and actually get some interference from them. And that
Mm,
interference can actually be energy that you can use to power something. But so in theory, that concept works. It is possible. But it now depends on how much power you get. So for example, I'm going to give an example of a Wi-Fi router. Your Wi-Fi router is probably most of the Wi-Fi routers use a 12 volt 1 amp power supply. So 12 volt 1 amp, that's 12 watts of power that the Wi-Fi, part of that energy is going to the antenna, and that power that it radiates is going to be a lot less than 12 watts. Most of it is going to the modem within the Wi-Fi that's decoding and encoding the information that's passing through it. And then what's left goes to the antenna. So the antenna, well, according to the FCC, FCC is basically the Federal Communications Commission, if I'm not mistaken. They set standards for communicating devices in terms of, yeah, well, a bunch of stuff, but including the amount of power, the maximum amount of power that a communicating device should radiate. And their maximum is 2 watts. A device cannot radiate more than 2 watts of power if it's a device, if it's a consumer level device that's going to be used by a bunch of random people. And I think the European Union has theirs as well, and that's a little bit higher at, I think, 5 watts. Again, I'll have to fact check this, but I think it's around 5 watts. And that's the maximum that the transmitter, which is transmitting, can send out. But like I said, because of the nature of radio waves, they decay quickly. So by the point they leave the router and get to wherever you are or wherever the receiving device is, their energy has depleted to levels where it's now watts or even milliwatts, like less than a watt. And so for you to then get 500 watts from energy that's just radiating around you, that's yeah, that's a tough one. That's a tough one. Like even some commercial grade transmitters do not really use that much power. Like unless if you're now looking at um, something like LTE base stations, those might use that sort of power to emit, but it's because they have to emit that signal across like an 8 kilometer radius for most LTE base stations. And that's why they might need like 500 watts on one antenna. But for consumer grade electronics, stuff that you're going to put in your office, stuff that you're going to put in your house, stuff that you're going to put in your car or in your room, it's going to be a lot less. And so it's very difficult for me to then imagine someone getting that amount of power from waves that are just being radiated. Like, I would need to read a white paper on it and play around with whatever gizmo that MSED is to understand what really is going on. Because it's actually something that I'm very curious about in terms of understanding how we can use all this energy around us, because there is energy around us, which we can, in quotes, say free energy, but man, that's too much power to get from simple RF radio frequency. Like, no.
Yeah, I man, like, I'm trying to go on that whole tip of it's too good to be true thing, but like, yeah, like the white paper will be really interesting to see, and like also it being peer reviewed, be interesting to see what people in the field do when they see it, and I'm sure there are people out there who are already up to speed about this kind of stuff, like yet, and you kind of have formed a conception. But for me, on a just general consumer level, the doubt was there, and I'm like, okay, yeah, no, because I'm just trying to imagine, something like that is like super revolutionary. Like that's literally saying, we're going to start. We're no longer doing my electricity pole pylons. Tangwes and my emitters all over the place, which I'm like,
yeah.
And if that was the case, like I'm saying, Nobel Prize. But then again, the whole thing of impact on the human body and other things like that, like it's a lot. It's a lot to create that kind of electricity through radio frequencies. And what kind of concerned me a little bit was the size of the receiver on the back of the TV. So there'll be a picture, I'm guessing. If you're on the blog, it'll be the cover picture for the podcast. If you're on other podcast sites, but it's really small. I'm like, yeah, hey, maybe he's really pushed this to the nth degree in terms of what this is, how this can be possible. But I'm like, man, like this would have made global, like super global news, like this would have put Zim on the map. So I'm.
But even like
even
like checking out the image, like, yeah, like it's not clear enough for me to see what it is. But if this device is harnessing energy from radio frequencies, it needs to have antennas that receive that energy. And the thing is, so here's the thing. Oh man, I'm gonna nerd the heck out of this thing, but
man.
So what happens with antennas is certain signals that you're gonna emit need receivers of a certain shape so that you can get an efficient transfer of that signal from the atmosphere into that antenna. So you can't just have like any wire just sticking out. Like, it might work to receive some of the signal, but then there's the whole thing that involves polarity. So polarity is basically, is your wave upright or is it lying down flat? Is it vertically polarized or horizontally polarized? And so you actually need an antenna for such waves that corresponds to the wave that it's going to receive, so that you get the most efficient transfer of energy of that wave into that antenna. So that's the thing where I'm like, I don't see any antennas on this thing to suggest that it can receive radio frequencies. That's the first one. The second one, because there is a plethora of radio frequencies, there's no mention of which kinds it will actually be most efficient with. Is it going to be most efficient with Wi-Fi or Bluetooth or GSM or VHF and UHF that is used on radios and TVs? Like, you don't know, because there is no antenna or no specifications of what is the most efficient manner of obtaining that power from it. So for me, then it raises more questions than answers in terms of what's really going on. And then when I see the contraption that they built to the back of the TV, like, it looks like a power pack or a transformer of some kind. I wasn't
going to say it, but yeah, I was like, "How's my battery?"
Yeah, it looks like a transformer. it looks like a transformer of some kind, So it's one of those where I'm like, where can we get more information about it? Because think about it. If you look at conventional wireless chargers, you can get white papers around them to understand how they work. Like a manufacturer might come and say, hey, this wireless charger has a dual coil design. And the reason why it has a dual coil design is, well, mostly it's the whole efficient transfer of power to the device that's being charged. So it's just some innovations that they're doing to try and make sure that wireless chargers waste less energy when they're performing their duties. And I'm like, if that information for that stuff is easily available, why isn't this also as easily available, so that there might be someone who wants to implement gadget. So, okay, now I understand how this thing works. Can we miniaturize it so that it can fit maybe in a phone's pouch? And then this phone's pouch is fitted with a wireless charger so that this pouch can wirelessly receive radiation, convert it to electricity, and wirelessly charge the phone, stuff like that. But there's nothing. And even if you try to search for reports, more of these reports that are speaking about it, there is nothing at least for a person like me, there's not enough technical information in it for me to actually understand how it works. I mean, here I am, this whole podcast, theorizing on how I think it works, theorizing on how I think it should work. But yeah, like there's I don't know. I'm just guessing based on the stuff that I learned and the stuff that I know and the stuff that I experienced, but I'm not sure if that's even the way this thing works. So that then becomes the question for me, like, can we see a demo and some specs on how this thing works?
Yeah, that demo would really be good. Because I was going back to so the remote was made by Samsung and it's called the Eco Remote. I had forgotten the name of it, but basically it's radio frequency as well as solar. So a solar remote is kind of weird because if you think about it, a place where a remote usually is dark, and remotes are usually cast aside. So it would suck if you forget to like charge your remote and then there you are trying to switch on your TV and remember, oh, by the way, I didn't. But the addition of radio frequency, and again, the power demand, this is really low. So, most reports saying this actually makes sense because the power demands are really low. So I was like, okay, cool. And then like to see how Samsung even went over and above that and started like it incorporating stuff like kinetic power generation, trying to shaking the remote in order to charge it and things like that. To be like, yeah, no, this is something else that they were looking into to try and do that, but then it wasn't really feasible. On the whole solar part, I think Zimbabweans wouldn't really have a problem with it because Zimbabweans put those little solar lights on the window every time. So yeah, solar remote control is not too far afield.
Works.
Yeah, but yeah, it's the kind of the way they piled on technology in this little eco remote, what Samsung did shows, at least to my understanding of radio frequencies and power generation, that yeah, you have to put a lot around it for it to kind of make sense, like for it to work. So had they just said we got a radio frequency like remote, I'm like, dope, it is what it is. And they showed a demo at CES. But the addition of solar, that's the thing that clicked in my head, like, no, this, yeah. And the funny thing is, if you look at the image, the reflection of the image, there is nothing behind it that suggests that, because it's a bunch of sofas. So maybe I'm nitpicking at the picture, but I would expect to see a big enough array of antennas to be like, yeah, or directional antennas to be like, yeah, we're pointing specifically at this thing because this is how it can. That maybe might have made sense, but again, like you said, without a white paper, yeah, it's a difficult.
Oh yeah, it's pretty tricky. And like, I like the fact that you pointed it out that as much as Samsung is using the same sort of technology on remotes, they have a bunch of other additional power sources around it, because I think they understand that, yeah, in theory it works, but it's not yet at a point where it can be a standalone power source for even one of the least power demanding devices available on the market, because a remote doesn't use, a remote uses very little power, like very, very little power. And so if that sort of power source is struggling to just power a remote control on its own, imagine it, 55-inch TV. Yeah. Nah. No, not yet.
Yeah, that for me is if that is possible, like, wow. And the amount of testing you'll need to go through, like, to make it to the point that it's like safe for consumers, because like all the super high-tech stuff is never really, like what you said earlier at the beginning, is never brought out to people up until it's been tested to death that it's not going to harm people.
Yep.
So remember the whole microwave thing, and people are like, oh, microwaves do this and that, and like, yeah, they kind of went through tests and these things are still being sold. So the teams behind it kind of have a handle on how it works. So even phones, remember back in the day when they say all phones do this, do that, and it's like, do they know? Like, then the 5G thing with COVID, and you're like, hey, yeah, completely different disciplines of science, but okie, you know what?
Exactly.
You do you.
So, do you, man.
So I don't know, man. Like I'll really like to see a white paper on this. I think it'd be interesting to read through it to just see what exactly what kind of technology is. Also, that MSED, was it MSED or MSED?
Yeah, MSED
device is the acronym was not then explained in the report by the Herald, but that would be really interesting to know what that is. Because
that seems to be the magic sauce for this thing. Like because when they're saying we can, well, according to the quote, they were saying right now we are miniaturizing the MSED to be smaller so that we can integrate it in cell phones, computers, laptops, and decoders. And I'm like, okay. So it means this thing is that's what's doing all the work. That's what's doing all the harnessing of RF and converting it to usable power. So what is this thing? That's what I want to know. Like, what is, like, okay, fine, we can start with the acronym. What does the acronym mean? And then from there, we kind of understand, because what I know about products is, yes, there is a patent that you file that will have the specifics of the product that you made. But before you get to the point of a patent, there is a sort of a proof of concept sort of thing that you just design that theorizes. It can be something like even a block diagram, just saying, hey, there is this component here, this component here, this component here. And these components, the flow of how this thing will operate is, we're going to start with our RF here. It's going to go through these blocks, and then it's going to come out as electricity over here. So it's just a simple thing like that, even without the specifics of, hey, we have 10 million transistors here and 5,000 capacitors there. Like, just a simple block diagram to just show us what's in this MACD and how is it going from RF that's in the air to electricity that's now powering something else. Just so that, you kind of get to see like a bit more insight on how this thing actually operates, and if it can work or not.
Yeah. So before we dive back into the weeds, Ed, thank you very much, man. We sincerely actually want your comments on this, because like I know they are really smart people in the technical community. Drop in the comments, what do you think? Is this even possible? Hopefully we get to see a white paper soon. The report in the Herald was really, really short. I think it was Sunday Mail first, and Herald was super short. So it was like,
tiny.
I want more. But it was that. So thank you all for listening. I guess we'll catch you again. I don't want to say soon. I'll say next week.
Next week.
Peace.
Au revoir. Peace.